What would it feel like to see all 10 dimensions of the universe at once? Zero dimension. The point. The zero dimension is a point with no dimensions at all. Although a true mathematical point does not exist physically in reality, we constantly use the concept. For example, when you navigate somewhere using your phone, the location shown on the map represents a zero-dimensional point. It has no size, no shape, and no volume. Even though we can mark it on a map, we cannot see such a point in the real world. It simply represents a precise coordinate in mathematical space. First dimension, length. If we extend a line from a zero-dimensional point, we create the first dimension, length. A one-dimensional world has no width or height, only length. It can extend infinitely in two directions. Imagine standing on a perfectly straight road where you can only move forward or backward, but not left, right, up, or down. Movement exists only along that line. Between any 2 points on this line, there are infinitely many zero-dimensional points. Second dimension, width. If we expand a one-dimensional line sideways, we create a two-dimensional plane. A two-dimensional world has length and width, but still no depth. If two-dimensional beings existed, they could move forward, backward, left, and right, but they could never leave their flat plane or perceive objects with depth. The concept of width is everywhere in our daily lives. For example, when you try to pass through a doorway, your brain subconsciously calculates whether your body's width will fit through the opening. Third dimension, depth. The third dimension adds depth, creating the three-dimensional space we live in. This dimension allows us to perceive volume, distance, shape, and size, giving us the rich sensory experience of the physical world. In 3 dimensions, we can move freely, forward, backward, left, right, up, and down. But the universe may not be limited to just these 3 spatial dimensions. Fourth dimension, time. In modern physics, time is often considered the fourth dimension. Time connects past, present, and future, allowing events to unfold and giving meaning to cause and effect in the universe. You can imagine time like the progress bar of a movie. You can rewind, pause, or fast forward a film. In real life, however, time seems to flow in only one direction, from the past toward the future. According to Einstein's theory of relativity, time is not absolute. It can pass at different rates depending on speed and gravity. This effect is known as time dilation. For example, a clock moving at extremely high speeds or near a very strong gravitational field such as a black hole will tick more slowly relative to an observer far away. The movie Interstellar famously illustrates this effect. Higher dimensions. From this point onward, things become far more abstract. Human intuition is built around 3 spatial dimensions, so imagining higher ones is extremely difficult. It's similar to asking a 2-dimensional creature to visualize a 3-dimensional sphere. It could only see changing circles or lines, never the full object. Fifth dimension, possible timelines. One speculative idea proposes that the 5th dimension contains different possible timelines of the same universe. Imagine a large tree. Each branch represents a different decision or outcome in your life. Every choice could lead to a different version of events. In theory, the 5th dimension would contain all these alternative timelines that share the same initial conditions but diverge due to different outcomes. Note, this is a conceptual model often used in science communication, not a confirmed physical reality. 6th dimension, all possible timelines. The 6th dimension can be imagined as a space that includes every possible timeline that could arise from the same starting universe. From this perspective, you could compare all possible histories of that universe, from its beginning to its possible futures. Again, this is a theoretical way of visualizing higher dimensions rather than a proven physical structure. 7th dimension, different universes. The 7th dimension expands this idea further. Instead of different timelines from the same starting conditions, it would include entirely different universes, each with different initial conditions or physical constants. Imagine a vast cosmic library where each book describes a completely different universe. Some might resemble ours. Others could operate under very different laws of physics. 8th dimension, the timeline of universes. The 8th dimension would then include the histories and timelines of all those universes. It would be like observing the evolution of every universe in the multiverse simultaneously, seeing how each one begins, evolves, and possibly ends. 9th dimension, all possible laws of physics. The 9th dimension represents an even broader possibility space. Instead of universes with different histories, it would include universes with every possible set of physical laws and initial conditions. In other words, every imaginable version of reality could exist somewhere within this framework. 10th dimension, the totality of possibility. The 10th dimension represents the ultimate limit of this idea. It would contain all possible universes, all timelines, all physical laws, and every conceivable reality. At this level, everything collapses into a single mathematical structure containing every possible configuration of existence. In such a description, distinctions like direction, time, and separate universes lose their meaning. All possibilities coexist within the same ultimate framework,